Good afternoon, everyone. I am Saurabh Borua. My presentation topic is evaluation of average speed estimation methods at signalized intersection using drone-based trajectory data. And my paper ID is 163. As we know that the average speed is the key measure for congestion monitoring, travel time reliability. Also, the signalized intersection have a stop and go traffic characteristic. Existing various sensors like Bluetooth, GPS, CCTV, loop detectors have uh, are used for average speed estimation, but all of them have some biasness. Drone-based trajectory data here is used for 12 variants of speed estimation methods. Those are in 4 different categories. Each of these method is benchmarked against full trajectory reference, that is M1 method. M1 is the distance weighted trajectory based method. The practical goal of this presentation is to provide guidance for real-time speed monitoring. Let's deep dive into the agenda. In this presentation, I have motivation, method, framework description. In the third part, I have the study setup, how I collect the drone data. In the fourth step, I have results comparison, a statistical significance study. And finally, in the fifth phase, I have practical guidance for real-time monitoring for speed estimation. Let's firstly comes why we need this study, because signalized intersection and it has stop and go traffic. It is much more challenging to estimate average speed, and different methods have different speed estimation using same traffic data. We use these in this study. Actually, there are limited guidance for most reliable average speed estimation method for urban intersection. And drone-based trajectory enables the fair comparison among different uh, average speed estimation techniques. The necessity of this study is to identify most accurate and practical traffic monitoring using the average speed. We can see with the infographics on the right side here. The objective of this study, as I said, systematic evaluation of 12 average speed estimation variants. Those are grouped into 4 categories. M1 is the full trajectory-based method, which is the benchmark, and all the data are collected using drone-based trajectory. M1 is the benchmark, which is distance-weighted trajectory-based method. M2 has 5 variants based on the vehicle selection rule, that use the entry exit travel time. M3 is the flow density based method, has 3 variants based on the uh, data aggregation sub window or sub interval. M4 is the spot speed averaging, which uses 3 variants of data aggregation intervals. Here comes some prior representative studies. We can see that the speed is estimated using video image sequence, license plate tracking, also use GPS device. Yellow V7 model is used with pose estimation in a study. Also use Bluetooth Wi-Fi matching. Differential GPS is also used for speed estimation. Automatic license plate reading, video, 3D reconstruction, dual cameras are sometimes used for average speed estimation. If we look at the framework over here, we have 4 categories of average speed estimation. The M1 is the benchmark, which use the distance weighted trajectory, can be represented by 100% pro vehicle penetration. It uses the full trajectory data, so it is data hungry. And M2 is entry exit travel time based method. It resembles by Bluetooth matching or automatic license plate method. There are 5 vehicle selection variants. In the third category, we have flow density based, which resembles by loop detectors or CCTV. I use 15, 30, and 60-second time interval, sub-interval. M4 is the spot speed averaging method, which resembles by CCTV spot speed detection. Similar to the M3, I use 15, 30, and 60-second aggregation time interval here. If we look at the M1 benchmark method, which use the aggregation of total distance traveled divided by total time spent, it same to the consistent with the ED's definition method. It use 100% vehicle penetration, vehicle penetration, so it requires huge amount of data, especially the high resolution trajectory data, because it use vehicle movement of every time stamp or every second here. So it's not actually that much practically recommended for real-time deployment. So and it's also data intensive. It is used for purely for comparison baseline here. If we look at the variant M2, which is entry-exit travel time variance, in this method is resembles records the entry time and exit time. Then we can calculate from the difference travel time and divided by the length of the route segment. So there can be 5 vehicle selection rules. Since we have used 5-minute time interval for every data, so within that selection interval, I use strict interval where vehicles entering and exiting within the 5-minute time interval are only considered. M21 variants where only entry of vehicle which entered within the 5-minute interval are considered. M22 where the vehicle exiting within the 5-minute interval are considered. So M21 is the entry based and is carryover, whereas M22 is the exit based, which represents or similar to the carry backward. In the M23, we use M2C, we use the combined weighted average, where M2, the strict interval, entry based and exit based vehicle count selection method are combined together by weight to balance the biasness. M23 is actually same to M2, but it has it used the only midpoint of entry exit time stamp or vehicle. The calculation procedure is same. Calculation procedure is different, but the data selection or the vehicle selection rule is same to M2. In the M3 variants, where we have flow density based method, we calculate the flow, which is the entry exit number of vehicle entry exit within the 5-minute time interval. Average of it is considered. Then the density is calculated by the snapshot at the midpoint time in or midpoint of this time interval. After that, the flow is calculated, the speed is calculated by flow by density. Whenever we use the total 5-minute interval from the sub-interval, here we use the vehicle second as the weighted average. We have 15-second sub-interval, which is high granularity and has more noise. 30-second sub-interval, which is comparatively balanced little bit, and 60-second sub-interval, which is much more smoother and less responsive. It is coarser actually also. If we look at the M4, we can see that the M4 is a spot speed based method. Here also 5-minute time interval is used, but for the sub-interval aggregation, we use 15-second snapshot, 30-second and 60-second snapshot. Since this method use instantaneous spot speed taken from the full 106-meter study segment. and it similar to CCTV study. Uh, like previous method, the weighted average of each sub-interval is aggregated using, and the weighted average is the vehicle second is the weighted average. And here it comes the study area. My study area is Sathon Convent intersection. And we can see that the trajectory, the time-space trajectory is drawn from the drone data. And so the traffic data was collected in 3 different dates. Total 16 5-minute time interval data were analyzed. The trajectory data resolution was 1 second. And data were the video data processed using computer vision platform named Data from Sky, and we use georeferencing up to 0.1 meter with 0.1 meter positional error. The Data from Sky provided vehicle IDs, position, XY position, timestamp, and also the speed of the vehicle. The operating condition of my study section, I was found 158 to 259 vehicle for traffic volume, and green time ratio was 0.28 to 0.53. The density varies approximately from 27 to 57 vehicle kilometer per lane. Average speed ranges from 8 to almost 19, 8.79 to almost 19 kilometer per hour. For performance measure, since M1 is the benchmark method, it compares with the percent deviation. We can see the positive means the overestimation, negative means the underestimation. The vehicle speed estimated using any method minus the vehicle speed estimated corresponding in M1 divided by the corresponding M1 method, and is 100% is give us the percent deviation. We can see here is the estimated average speed by different 12 categories, variance of total 4 categories of average speed estimation. We can see in the 3 different time study time, we can see the calculated estimated average speed is presented in the bar plot here. If we compare with the M2 result, that is entry exit based travel time based method with the distance weighted trajectory method, M2C performs best, which has only 3.81% mean absolute percent deviation. M2 and M2C is little bit overestimated. M21 is underestimated. M22, which has less bias, obviously. If we look at the M2C, that is combined weighted method of entry exit travel time based variance we can see that it has no significant difference with the statistically no significant difference with the benchmark M1 method, and it is most reliable within the M2 within the other variants of among the other variants of M2 method. If we compare the flow density based method with the distance weighted trajectory method, we can see that the M3 30, that is 30 second aggregation, sub-aggregation, we can see that the mean absolute percent deviation is 3.21, which is the lowest, and it has no significant difference than benchmark M1 method. It is most preferred. M315, that is 15 second aggregation, has slightly underestimation, and M360, that is 60 second sub-aggregation or sub-interval, we can see that it has lowest accuracy comparing to other method. It provides it cannot capture actually traffic dynamics properly. If we look at the M4 results, that is spot speed based method with versus the distance weighted trajectory, we can see that the M415 performs best. It has least mean absolute percent deviation and mean deviation. However, we can also look at the M430, that is 30-second sub-interval, sub-aggregation interval. It has also good accuracy. Its mean absolute percent deviation is only 5%, and its mean deviation and max deviation varies around 10%. Whereas M416, we can 60, that is 60-second interval, has lowest accuracy. It is less preferred. If we compare with the M415 and M430, we can actually prefer M430 because it's statistically significant. Also, the M415 is also statistically significant. But M430, which is 30-second use the sub-interval, it takes less number of sampling compared to the 15-second aggregation. Almost half, it takes half amount of sampling effort. So it obviously time and effort effort less consuming, more efficient compared to M415. So M430 we can consider here also. The key finding is M2C, which is weighted combined weighted entry exit travel time based method. We can use this within other variants of entry exit travel time method. It has less biasness due to weighting average, using the weight average. Within M3 and M4, the flow density and spot speed based method, 60-second windows perform actually worst. 15 and 30-second interval has less than 10% deviation compared to the baseline or benchmark M1 method. However, we can choose especially the 30-second interval, say for the M330 and M430, because considering the best practical trade-off, it has highest accuracy and much lower data sampling it requires. If we look at the recommendation here, if we look at the accuracy is the priority for the combined weighted entry exit travel time based method, which is M2C. It is resembles with the automated license plate method, has the lowest mean absolute percent deviation. For M330 and M430, considering this, we can consider the balancing the cost and accuracy. They have deviation mostly within 5 to 10%, not more than 10%, comparing to M1, and it takes less sampling requirements or needs, almost half than 15-second variants. So we can choose if we consider balancing cost and accuracy. Another thing is if we take very large sub-interval aggregation, like 60-second aggregation, for M360 and M460, M360 is the flow density based variance and M460 is the spot speed variance. We can see that they have large deviations, almost 20 to more than 30%, which is less suitable for operational decision making at signal intersection based on average speed estimation. Here is the conclusion and future works. The drone-based trajectory enables systematic high-fidelity data for average speed estimation. We have a benchmark to benchmark and compare with the benchmark method. We can deploy it for real time at signalized intersection. Total 12 methods, 12 variants of 4 category of average speed estimation method with one M1 benchmark method is here used here. The single intersection is only on Sathon Convent of Bangkok is used for the case study here. These results provide the methodological validation, not universal ranking. Obviously, we have to take it to consider. Future research, we can consider various type of traffic volume and signal strategies. We can extend our road geometry, use different type of road geometries and valid across multiple urban environment so that we can actually build the universal ranking. Also consider the overall average speed estimation strategies for generalized purpose. And thank you so much. If you have any question, you can ask me.